Congruencies of a triangle. Centroid, G. So here we have a triangle, and we see that the point G is labelled in the centre. So this is known as the centroid. A median of a triangle is a line segment from a vertex corner to the midpoint of the opposite side. So for example, if we take the side AB, we can see that this point here is the midpoint of AB. It's the halfway point. And we know this because we have three little lines on this length and then another three little lines on this length. So that tells us that this line is equal in length to this line. So this must be the midpoint of AB. And we can see that that midpoint is joined to the opposite corner or the opposite vertex. And this line that's joining them is known as the median. We can see it on all sides. So on the next side, we can see that this is the midpoint of that line, and it's joined to the opposite vertex or corner. And then on the other side of the triangle, we can see that this is the midpoint, and that is joined to the opposite vertex or corner. So a median of a triangle is a line segment from a vertex or corner to the midpoint of the opposite side. The three medians of a triangle meet at a point called a centroid G. So these three medians meet in the center, and this is known as the centroid. And G, the centroid, divides each median in the ratio of 2 to 1. So for example, this median here, the distance from here to here is twice the distance from here to here. So it's in a ratio of 2 to 1. Likewise, this median is in a ratio of 2 to 1. And this median is in a ratio of 2 to 1 also. And to get the coordinates of G, we take all the x values and add them and divide by 3, comma, take all the y values and add them and divide by 3. Circumcenter O. The circumcenter of a triangle is the point of intersection of the perpendicular bisectors of the sides. So bisector means to cut in half. So here we have a circle, and inside the circle we have the triangle A, B, C. If this is the length AC, then this is its perpendicular bisector. So it's a perpendicular angle, so a 90-degree angle, but it's also bisecting, so cutting the line AC in half. And we know that because we've got two little lines and two little lines, which tells us that this length is equal to this length. So here we have the perpendicular bisector of the side AC. Likewise, this is the perpendicular bisector of the side AB. And likewise, this is the perpendicular bisector of the side CB. So the circumcenter is this point of intersection of the three perpendicular bisectors, and it's labelled here as O. Orthocenter H. An altitude of a triangle is a perpendicular from a vertex or corner to its opposite side. So here we have the side AC of the triangle, and here we have its perpendicular line, and we know that because of this square, this right angle, and it is joining to the opposite vertex or corner. Here is the side AB, and here is its perpendicular. We know that again because of the 90-degree angle, and it's joining with its opposite vertex or corner. And here we have the side CB, and here's its perpendicular, and it's joining with the opposite vertex or corner, which is point A. The orthocenter is the point of intersection of the altitudes, and it's labeled here as H. So it's the point of intersection of the three altitudes, and that is the orthocenter. Note, the centroid, circumcenter, and orthocenter in a triangle all lie on a straight line called Euler's line. Some people pronounce this as Euler, so Euler or Euler, Euler's line. Incenter, C. The incenter is the point of intersection of the bisectors of the angles in a triangle. So remember, to bisect something means to cut it in half. So for example, if this is the angle CAB, then this is the bisector of it. So we can see that we have one little line on that angle and one little line on that angle, which means that these two angles must be the same. So this line here must be cutting the overall angle in half. So here we have the bisector of this angle. Likewise, here we have the angle ACB. So we have three little lines and three little lines, which tells us that this line is cutting the overall angle in half. So this angle is equal to this angle. So this here is the bisector of that angle. And again, we have the angle ABC. And this line here is cutting that angle in half because we've got two little lines and two little lines, which tells us that both of these angles are equal, which means that this line must be cutting the overall angle in half. So we have three bisectors. So the incenter is the point of intersection of these bisectors. So we can see that these three lines intersect at this point here, C. So this is the incenter. Finding a bisector of an angle, and hence the incenter, is not on the coordinate geometry section of the syllabus. So you won't need to find the bisector of an angle, and therefore its incenter, but you do need to know what the incenter is. A minus 2, 7, B, P minus 4, and C, 4Q are the coordinates of the vertices or corners of the triangle ABC. If the coordinates of the centroid of triangle ABC are minus 1, 3, find the value of P and the value of Q. So we need to figure out what P and Q is. So here's a triangle. We're going to label it A, B, and C, with A being x1, y1, B being x2, y2, and C being x3, y3. So the centroid of a triangle is the intersection of the medians. So if this is the line AC, then the median is the midpoint of the side AC joined to the opposite vertex or corner. And then the midpoint of AB, or the median of AB, is the midpoint of AB joined to the opposite vertex or corner. And the median of CB is the midpoint of CB joined to the opposite vertex or corner. And the point of intersection of these three medians is the centroid. And the coordinates of the centroid, x, y, are given by x1 plus x2 plus x3 divided by 3, comma, y1 plus y2 plus y3 divided by 3. So we're going to take our points we're given at the start, label them x1, y1, x2, y2, x3, y3. So all the x's highlighted in yellow are going to be added together, divided by 3, and this will end up giving us our x coordinate for our centroid. Now we know that our x coordinate of our centroid is minus 1, so it's going to end up being equal to minus 1. So we swap x1 for minus 2, x2 for p, x3 for 4. That's all divided by 3 and equal to minus 1. We simplify. Minus 2 plus 4 is 2. So we have p plus 2 over 3 is equal to minus 1. We multiply across by 3 to get rid of the fraction. We get p plus 2 is equal to minus 3. And then we solve for p, so p is equal to minus 5. So we've now found the value of p. All we have to do now is find the value of q. So likewise, we take all our y values, highlighted in green, and we're going to add them together, divide them by 3. So all our y values added together divided by 3 will be equal to the y value of our centroid, which we know is 3. So we swap our y values. So we have 7 minus 4 plus q is all over 3. And that's equal to 3 because we were told in the question that the y value of our centroid is 3. Then we simplify. 7 minus 4 is 3. So q plus 3 over 3 equals 3. Then multiply across by 3 to get rid of the fraction. So we have q plus 3 is equal to 9. And solving for q, q is equal to 6. So now we found the value of q. So the value of p is minus 5. The value of q is 6.